In this problem, a 10 kilogram object moving at 10 meters per second and a 15 kilogram object moving at 20 meters per second in the opposite direction, and they collide in a head-on elastic collision, and we are asked to find the velocity of each object after the impact. So let's start by visualizing the problem. I'm going to draw a diagram for the initial situation and for the final situation. And I'm going to take right as positive x-axis. Initially, 10 kilogram object has a velocity of 10 meters per second. Let's assume it's moving to the right. The mass is 10 kilograms. The second object is moving in opposite direction. So let's assume it's moving to the left. Mass is 15 kilograms. Velocity would be negative meters per second, 20 meters per second based on our coordinate system. And after the collision, we don't know the exact direction of the object. So it can be moving to the right or moving to the left. So I'm just going to draw a diagram with a question mark for the final velocities. Definitely they are going to have two different velocities. Mass 1 is just 10 kilogram. Mass 2 is 15 kilograms. So applicable concepts, this is conservation of linear momentum, and have it specified the coordinate system. Yes, we have taken right as positive, and we are trying to calculate the final velocities, and the unit is meters per second. It can be either positive or negative. We can expect to have a negative value because if we calculate the initial momentum of the system is negative. Okay. So we can use these two equations. These equations are listed in your equation sheet, guys, under elastic collisions. The second equation, I'm sure you're familiar with the first equation by now. The second equation is not commonly used, but it is a derived equation. It's given in your equation sheet. So please make sure to go and have a look at it. And let's execute the plan now. So I'm going to just use the equations I listed under the plan. Initial momentum of the first object plus the initial momentum of the second object would be equal to final momentum of the first object plus final momentum of the second object. 10 kilogram times 10 meters per second, 15 kilograms times negative 20 meters per second is equal to 10 kilograms times final velocity of the first object plus 15 kilograms times final velocity of the second object. And then I'm going to use the second equation, but let me solve this before that. So 10 times 10 is 100, 15 kilograms times 20 is negative 300. So I end up of getting negative 200 kilogram meters per second is equal to this. And I'm going to label it as 1, and then the second equation, V1 initial minus V2 initial, is equal to negative V1 minus 1 final minus V2 final. So initial velocity of the first object is 10 meters per second minus 20 meters per second is equal to negative V1 final plus negative V2 final. And 10 meters per second minus 20 meters per second is equal to 30 meters per second, and that would be equal to negative V1 final plus V2 final. I'm going to multiply both sides of the equation by 10 kilogram. When I do that, I get 300 kilogram meters per second is equal to negative 10 kilogram V1 final plus 10 kilogram V2 final, and I'm going to label it as the second equation. And I'm going to copy down the first equation here. So you can see I have two equations with two unknowns. I multiplied by 10 kilogram earlier so that I can just add the second equation and first equation together and cancel out the 10 kilogram V1 final term. So that was my plan. So when I add first equation and second equation, I have to add all the terms on the left hand side together, all the terms on the right hand side together. 300 kilogram meters per second minus 200 kilogram meters per second. I got 100 kilogram meters per second. Divide that by 25 kilogram. I end up with getting 4 meters per second for the final velocity of the second object. And I'm going to substitute this value in the second equation. And once I do that, that would be 300 kilogram meters per second, negative 10 kilogram V1 final, plus 10 kilogram times 4 meters per second. You have to rearrange the equation and separate V1 final. You will get 260 kilogram meters per second. Divide that by 4, negative 10 kilogram. That would be equal to negative 26 meters per second. So as we expected, one of the two velocities is negative. So it's negative 26 meters per second. Okay, so is the solution complete? Yes, sign is correct. So we have completed the question. That would be it.